Hello, everyone. I am Abhay Saxena. I am a developer at Datawire, and I am the lead developer of Telepresence. There was another Telepresence talk earlier today done by my good buddy, Daniel Bryant. So he talked about the introduction, the overview. I'm going to talk specifically about debugging a service that's part of an application that runs in a Kubernetes cluster. So let's talk about developing software, right? I guess a lot of us are probably software developers out there. We have a process that we follow, right? We have a piece of code. We change that piece of code because we're adding a feature or we're fixing a bug, something like that. We build it, we run it. Sometimes we inspect it with some of our tools, right? Running piece of code can be somewhat opaque. You can see the inputs, you can see the outputs, but what's going on inside is not necessarily so clear. Well, we have fancy tools that help us look inside. We have your stochastic samplers, profilers, and debuggers, and so forth that lets you see what's going on, make your software a little less opaque, right? But you change your code, you run your code. You change your code, you run your code. That's the normal software development loop. Now, when you introduce Kubernetes, things change a little bit, right? You change your code, you build an image. You push the image to a container registry. You poke Kubernetes in some way, maybe you update your deployment or something like that. Kubernetes pulls the image and restarts your pods, and well, there you go. Now you can see your code running, right? It's a pretty long, somewhat slow loop. And let's talk about debugging in particular, because that's what I want to focus on here. Debugging software is hard, right? You have to be pretty clever to write a good piece of software. And then to debug that software, you have to be even smarter than that. And then when you're running in Kubernetes, the software is running far away from you. You're kind of isolated from it. You're typically not able to use most of your normal tools. I mean, yes, there are remote debuggers, and they do work in some circumstances if you can get everything exactly right. You can connect with your remote debugger to a pod in Kubernetes. It's not an easy thing. It's not an easy thing to replicate, and it doesn't always work the way you want. And then, so if you're not able to use your tools, right, you're basically left with print-style debugging, right? You can add some log statements, and you can run your code, and then you can see kube control logs and see what's going on there, and it's not the most interactive approach. So Telepresence can help with all of this. The short version is that Telepresence lets you run your code on your laptop, but your code thinks it's running in the cluster. It means your code can access the cluster, and the cluster can access your code. And this makes it possible to use all of your tools. I'm going to talk about IDEs and things like that. And that's basically what I'm going to do here. I'm going to do a series of demos showing you how to use Telepresence, how Telepresence lets you use your typical development tools. Okay? So we're going to go through an example application that represents what might be in a typical Kubernetes cluster. So we have some sort of request that comes in. Maybe it comes into an API gateway, and that goes to some service, and there might be some chain of services. And eventually, a request comes to our service, right? This is what causes our code to run. A request has come into our service, and our service is probably going to need information from other services in the cluster, so it's going to call out to other things there. Let's zoom into our service and see what's going on. Yeah, I know the slide says my service, but I'm sharing this debugging process with all of you, so it's going to be our service, okay? So we have to get information from other services in the cluster, and then we have to perform the interesting computation. Whatever it is we're doing, whatever the reason is that someone would call our service, we have to do that. And then finally, we return the result. So that's the shape of a typical service in your typical Kubernetes application, okay? Let's think about what can go wrong. You have a service, it's been running, it seems to be running fine, and then it starts breaking. It starts giving wrong answers, or it starts crashing, or something like that. Why would this happen? What can go wrong in these sorts of situations? Well, we're relying on other services in the cluster, right? And while we own our service, we don't necessarily own all of our dependent service, the services we depend on. Other teams work on those. They might be fixing bugs. They might be adding features and so forth. They can make mistakes too, right? So it might be the case that something that's worked fine suddenly starts failing. And now here's where it can be worse. Sometimes you have a situation where whatever it is failing only fails some of the time. Hey, I ran it in CI, it worked fine there, it works fine on my system, but it fails some of the time in production. What's going on there? So it can be really difficult to debug a situation like that, okay? So I'm going to start going through these examples, enough slides. So this first example is going to be a Java example, and I have a couple of others. Okay, so let's hop over to the editor. Yes, those are little notes for myself. So while the demos I'm doing work perfectly well on a GKE cluster or an on-premises cluster, wherever your Kubernetes cluster is, for the purposes of this talk, I am using a local cluster. It doesn't change anything except I don't have to rely on the conference Wi-Fi. So I hope you'll forgive me that little bit of cheating, perhaps. It's not really cheating because it all works exactly the same way. And the other thing is I have a tendency to use K instead of kubectl. It's just the kubectl command. It's just a bash alias. So let's take a look at what's going on in this cluster. I'm going to do a kubectl get deployments. And this is what we have. We have Ambassador. This is my API gateway. Sorry for the small text. I'm going to try to read out loud everything that's important. So Ambassador is the API gateway. When I use curl commands to access the cluster, that's what I'll be hitting. And then we have a bunch of other services running. In this case, we're going to be looking at the Java service. And the Java service and all of these other services all call into a base service that's also running in the cluster. Okay? So when I access the cluster, I'm going to use the curl command. I'm going to curl edge/java. And this is the output that shows up. So let me read this to you. It says, hello, KubeCon NA. Greetings from Java. And then there's this code. It's a base64 encoded string. And then there's some additional information after that. There is the host name. Shows you it's running on the java-blah, blah, blah pod. And there's a timestamp, just so you can see that things are changing. And the key point here is the big banner message up at the top has this nice box around it, because that's, we want a pretty answer for our service output. So I'm going to run this curl that I just did in a loop. I'm going to curl edge/java in a loop, and then echo to get a blank line, and then sleep for 1 second. Okay? And you can see the output scrolling along. And now, if we're a little patient, and I'm going to pause it at just the right moment, we'll see that there's a bug in this code. Well, there you go. So I've paused the output, and you can see this time, specifically, the output's not right. It doesn't line up correctly. The box isn't right. The code is too short. Something is wrong. Now, yeah, this is a pretty trivial example because we want to be able to debug this during the course of the talk. But I mean, an unexpected output like that can cause all sorts of things to break in a real system, right? So the goal is to debug this error in our IDE. So let's hop over to our IDE, okay? This is IntelliJ IDEA, and this is the Java code. I'm going to walk you through it real quick. This is the main function, and it's running on port 8000, and every access to / is going to run this code. This code does a call to get value, and I'm going to take a quick look at get value. This is an IDE. I can just hit a key and jump to that get value function. And this is basically the moral equivalent of a curl to the base service, right? So our service calls the base service as one of the first things it does. And then once we get that value, we do a bit of computation. In this case, the computation is we do a base64 encode of the answer we get from get value. And then we construct our little box. And you can see, basically, we're kind of assuming when we draw this box that the hash code is going to be the correct length. And so if the hash code is not the correct length, you're going to see that error that you saw. Okay? So we want to debug this code in this debugger. Let's get started. First, we need to, I'm going to hop back to the curl loop. You see that's still running. It's hitting the, oh, there's that bug. It's hitting the service in the cluster. I'm going to go to another terminal, and I'm going to run Telepresence. Let's not do it that way. I'll just type it out. Telepresence. I'm going to swap deployment, and the deployment I'm swapping is the Java deployment. And I'm going to run some sleep command just to keep Telepresence running, right? Because we're going to run the code in the IDE, in the debugger, okay? So Telepresence is running. If we hop back to our curl loop, oh, look, the curl loop is failing now. Why is it failing? Well, it's because we've replaced the code that was running in the cluster with a proxy that's redirecting those requests down to the laptop. But the laptop's not running anything. So that's why we're seeing errors. I've hopped back to the IDE, and I'm going to hit the debug button now, and that's going to run the code in the debugger. We wait for IDEA to do its thing and hop back to the terminal. OK, so now you can see the code is running, and in particular, you can see it's running on my laptop. The way you can see that is that the host name is now not some Java blah, blah, blah. It's Chill. Chill is the name of my laptop. My prior laptop had some cooling issues, some thermal management problems. This laptop's much better. So I named it Chill. Anyway, we can see that it's running on my laptop. I've unpaused it again so you can see it's updating. And again, if we are patient, we will see that the version of the code running on the laptop has the same bug. There we go. I will highlight this. You see, once again, the box isn't lined up because the output is wrong. Okay? So now, if we go to the IDE, how are we going to figure out why the box is wrong, why the output is wrong, right? Let's set a breakpoint somewhere around here where we can see what that hash code is. So we've hit the breakpoint, and I guess I have to scroll to the side a bit. Well, OK. Lo and behold, by a matter of chance, I've hit the bug. I'm going to hit continue, and let's see this without the bug. OK. So we see that the hash code is this 16-character string, right? What we've been seeing in our box. And how's that hash code arrived? Well, there's a base 64 encoding of the answer to get value, and that get value is returning salty 990.7. Okay? And if we keep hitting continue, we can see that number change. Every time we hit the breakpoint, that's 993.4, 993.7, et cetera. And you can see on the curl loop is paused because we've hit that breakpoint. The last answer we got was at 16 seconds past. And then if I hit the continue button, it runs through and pauses again. And you see now the last thing we saw was at 29 seconds past, right? So we are controlling the code that is running through the curl loop. Now, by chance, I've hit this. OK, my luck is really good here, but I'm going to pretend that I didn't hit that by chance, right? We could sit here hitting the button and not hit that by chance with very high likelihood. So instead, let's use the power of this IDE. We can set a conditional breakpoint, which says stop only if the hash code is too short. Now, I know it's that you can't read that at all. It basically says hashcode.length is less than 16. That is the condition for this breakpoint. So now when I hit continue, it's going to keep running until we hit that breakpoint. And you'll be able to see the curl loop runs and runs and runs. And we're going to have to be patient because that bug is intermittent, even though I happened to hit it by chance a few times. All right, we seem to have stopped. Let's head over here, and we see, oh, look. The value that we're getting is salty 999. It's not salty 999.3. And I guess in this case, it would have been salty 999.0. But something changed at the other end, and that's no longer the case. So using our conditional breakpoint, we've been able to get the system to run and show us the error. That is the value of the debugger being available to you to run on the service that would otherwise need to run in Kubernetes. Okay, so I've hit the stop button, and I'm going to close out here because I think we should take a moment to figure out what we just did. Okay? And just hopping back to a curl loop, you see because I quit the debugger, the code's not running. And let me close out of Telepresence. Telepresence will now put everything back to the way it was. And now if we hop back to the curl loop, you see the curl loop is once again hitting the pod. OK, let's take a breath and figure out what just happened. Okay? We just went through the swap deployment workflow. Essentially, we replaced the code that was running in the cluster with a proxy that sent every request down to the laptop. Then we ran the code on the laptop in the debugger, stepped through the code to see what was going on. And every time we ran the code and let it run to completion, the result would, in fact, go back up to the cluster, back through the API gateway, and down to my curl command, where it shows up on my console. So this swap deployment workflow let me debug my application as if it were running in Kubernetes, but stepping through it in my IDE. Now, swap deployment means that we have the power of the IDE at our disposal. Sorry, that wasn't what I meant to say. Let's move on to more demos. I'm going to do another demo, a similar demo using Node.js and JavaScript. Okay? So I'm going to set up the same curl loop, but I'm going to curl the node service. Okay? And I am going to hop over to Visual Studio Code, which does a great job with JavaScript. And the code is basically the same thing. We call getValue to access the base service. We run a base64 encoding on the value, and then we emit this output. Hello, KubeCon NA, greetings from Node.js, and then the code, the hash value. So let us do the same swap deployment trick once more. So Telepresence, swap the node deployment. There we go. So now, once again, we see that the curl loop is now failing to connect because we haven't run the code. So let's hop over to the debug section and hit the go button, debug. And now the debugger's running. And so we should be able to see, let's see. Did I set a breakpoint unintentionally? It looks like I set a breakpoint unintentionally. Let's hit continue. All right, so now we can see that the host chill, which is my laptop, is serving these requests thanks to Telepresence. And now I had unintentionally set a breakpoint. Now let me intentionally set a breakpoint right here, and we hit that breakpoint, and we can once again see, well, okay, I guess you can't see it, but I will tell you that this value that we're using to compute the hash is salty 977, wow, it's even tiny for me, 0.8, okay? Now, we already know what the bug is. Let's take advantage of another feature of debuggers. I don't have to wait around for the situation of the error condition happening. I can just edit this myself. The debugger lets me do that. It's one of the features of being able to use a debugger. So I've edited the value. I have, in fact, edited the value too late. The hash value has already been computed, so editing the value now doesn't help. That was silly. Let's set the breakpoint a little higher and try that again. Okay, I'm going to hit continue. And this time, we're going to hit a breakpoint a little bit earlier. And now I'm going to set the value of this dependent value to 972 without the 0.5. And now we should see, as we understand, that the hash value will be incorrect. So I'm going to hit continue. And I'm going to hop back to my console. And we see, lo and behold, I have created the erroneous condition without having to wait around for it. Let's do that again. Let me make this clear. Rather than waiting around for the bad situation to occur, I am making it happen manually so I can step through the code and figure out what's wrong without having to wait around for the bad situation. Once again, I have created the bad situation manually. So this is one of the other powers of the debugger, and it really lets you cut through a lot of waiting around if once you figure out how to create the bad situation and why things are failing. Okay, so I've quit out of the debugger. Same as before, I'm going to quit Telepresence, and things will get switched back to normal. And then once again, the curl loop is going to be curling into the cluster. Okay, so let's talk about one more thing. Here's another situation that arises. You have multiple containers. A common case of this is I have an application that needs to use a cloud database. Typically, the way you'd use a cloud database is you have a sidecar, or I guess a proxy container, that connects to the cloud database for you, and you just treat the container as a local Postgres or local MySQL or MariaDB, sorry, whatever it's called these days. So when you have an application like that, when you have a service like that with its own database, sometimes if you're running into problems, you might want to see what's going on. Can I just inspect the database? If it were a local application, you would just spin up your database, your favorite database tool, and just connect to the database and take a look. Now, if the database is running via Cloud SQL, Sidecar, et cetera, it's a little more complicated to do that. But Telepresence makes it easy. Let's do this right now. Let's look at this pod. This is kubecontrol get pod, and the pod is, it has two containers. And I'm going to run a swap deployment on that pod. Telepresence, swap deployment, whoops. I'm going to swap this deployment, and I'm going to swap the app container, not the database container, because the database container needs to run in the cluster. And I'm going to run PGCLI, which is a very nice console-based Postgres client. Some of you may already know it. It gives you nice little tab completion and drop-down menus of like what you might want to type next and so forth. Now there's a problem. It says connection refused. Is the server running on localhost and accepting TCP connections on 5432? Well, it certainly is, but it's running in the pod, right? So when my application, when the code running on my laptop tries to connect to localhost, this is not Kubernetes networking. This is localhost networking, and that's not going to reach the pod automatically. So we had to implement a workaround, a flag to help work around this problem. So I want to use this PGCLI to inspect my database. So I'm going to set up this to-pod flag, which basically tells Telepresence that I want to take localhost 5432 and forward that to the pod. And there's an equivalent from pod option as well to go in the other direction. And Telepresence tells you forwarding localhost 5432 to the pod, okay? And now you can see PGCLI has started up. I can use all of my great commands. This is a really nifty program that like lets you complete all of these things. And so I ran the describe tables command, and of course there are no tables because once again, conference Wi-Fi, I don't want to depend on that, so I'm running an empty Postgres container instead. But this would work exactly the same way with a Cloud SQL container. So there you go. I was able to use another one of my favorite development tools, or in this case, I would be using it for debugging my database. And by using Telepresence, I was able to access the database running in the cloud or through the cluster. Okay, so that's the multiple containers example. So let's talk about swap deployment, right? We have seen that I can use it to go through my code, my service, via an IDE, or use another tool like a database tool to access stuff in the cluster. And this lets me do all sorts of things that would otherwise be very difficult with a Kubernetes service. Now, there's a trade-off. Swap deployment is relatively brain dead, meaning it just forwards every single TCP connection down to the laptop. And this is great if you use some weird custom protocol, or if you're Redis, or if you're Postgres yourself. And of course, it works for HTTP just fine. But there's a downside to this. Because Telepresence doesn't understand your protocol, it has to literally forward every single connection to your laptop. So if there's anybody else using this cluster, using this application, they're kind of stuck. While you're using swap deployment, they can't really use the application, because if you're stepping through the debugger, that service is not running for anybody else. So that's the trade-off with swap deployment. What if we could do better, right? What if we could introduce one constraint, a significant constraint, but do better as a result? So the constraint we're going to introduce is that your application has to accept HTTP requests as its input. Now, HTTP includes things like gRPC, so it's not a super horrible constraint. It's still a pretty significant constraint. The side effect is Telepresence can now know what your protocol is, and it can make decisions based on the headers in the request. So what we're going to show here is intercepting a particular subset of requests and sending just that subset down to the laptop and letting the rest of the requests flow to the pod, business as usual. Okay, let's go do this. So I'm using a different command right now called edge control. And edge control is part of the Ambassador edge stack, which is going to be released by Datawire on December 10th. And we're going to integrate this with Telepresence. So edge control shows that there's one interceptable deployment. What that means is this deployment has opted in to being interceptable. Essentially, it means that I have set up the deployment. I have configured the deployment to make this possible, where some of the other deployments we looked at, the Node deployment and the Java deployment, I did not do that. Anyway, let's set up an intercept for this deployment. Okay, I'm going to intercept the Python deployment. I'm going to name this intercept dev. I'm going to match, let's say, the xdev header, and I'm going to look for xdev equal to, I don't know, 1, 2, 3. And when I get that xdev123 header, I want to redirect that subset of requests to port 8000 on my machine. Okay? So what did I just do? I'm going to list these intercepts, and it says the intercept called dev is intercepting requests to the Python deployment. When the xdev header says 123, it will redirect this to my machine port 8000. Okay? And let's run something on my machine port 8000 so that it has somewhere to go. I'm just going to run the Python version of the same old service because I wrote 5 different versions of this service, and this is handy. OK, so if we go back to our curl loop, let's set up the curl loop to hit the Python deployment. And we see I've already run the intercept, but these curls are all hitting the cluster. They're hitting python-blah. That's the pod in the cluster. And if I go over to this terminal, I can run the same curl manually. And we see it's hitting the cluster, right? Python-blah is the host. But if I add this header, xdev123, now the curl is being served by chill, my laptop. And I can even hop over to this Python script, and you can see there is a single request being logged now. Once again, basic curls go to the cluster. Curls with the header go to my laptop, right? And the curl loop in this terminal continues to go to the cluster. So this is really a big deal if you think it through, right? You have a cluster that's serving 100 developers. Oh, that's kind of silly. A lot of developers, and they're each working on different pieces of a big application. I can intercept one or more deployments and just use my dev header to get those requests come down to my laptop. Meanwhile, everybody else can keep going on business as usual. Another developer might be adding a feature, and she can intercept the same deployment and get a different subset of requests going to her laptop. So this allows you to do a much more powerful set of things. I'm going to kill this curl loop without affecting everybody else in the cluster. So the trade-off, of course, is that you can only do this with HTTP. And just to clarify, if my service needs to reach something in the cluster, like a Postgres or a Redis or some other custom protocol, that's fine. That's no problem. The point is, for the intercept to work, to intercept requests to come down to my laptop, that has to be HTTP. So it's a trade-off. It is a constraint, but it's not a horrible one. We are really excited to roll out Intercept in the very near future. December 10th is just a couple of weeks away. So we're reaching the end here. Let me summarize. So Telepresence, that's where we saw the swap deployment workflow at the beginning. That is a CNCF sandbox project. We could use your help. We could use pull requests, features, bug fixes, documentation, everything. Telepresence.io, and obviously we are on GitHub. And then the last thing I showed is the intercept workflow. This is a part of Ambassador Edge Stack by Datawire. Ambassador Edge Stack is being released December 10th. And you can find out more on getambassador.io. Let me just show you, because I didn't update the slide. If you go to getambassador.io, there is a big banner at the top that tells you how to get to EdgeStack. But in any case, so that's being released December 10th, and we're going to have telepresence integration for the intercept workflow at that point. And that's about it. So if you have questions, of course, I'm going to hang out here, and then I will be at the Datawire booth, booth S46. Thank you very much for your time. I hope this was interesting and helpful. So I have a few minutes. I guess, do we do mic'd questions?
Yeah, if folks want to come up to the microphones to ask questions, there's 2 on the other side of the stage here. And also, quick reminder, please rate this session in the schedule as well as other sessions you've attended. It really helps the program committee with deciding how to future KubeCons.
And it helps the speakers, too. Please be honest. Oh, yeah, so if you ask questions now, I can actually use I can use my terminal and do things. Whereas if we do questions later, it'll be a little harder to do that. Question?
Yeah, so if you have configuration like environmentals or files that you mount into your container, would those have to match what would be in your cluster if you're doing telepresence?
Excellent question. So telepresence, the swap deployment workflow maps environment variables and volumes down to your laptop. Now, volumes are a little tricky because it can't put the pod's root file system on top of your root file system, so it mounts under a subdirectory. So there's a little bit of work to do there. You might use symlinks to connect things to the right place, or you might, if you're using a Docker run, you can actually use volume mounts to mount things in the right place when you need them. Environment variables get passed through. If you're using an IDE, IntelliJ has a .env file format plugin, and Telepresence will write an env file for you that you can bring right into IntelliJ. So the intercept workflow doesn't cover that as well yet, but we're still working on it. Next question?
You're just adding to that previous question. Does the same thing work with secrets?
So secrets are mounted typically as either environment variables or volumes. So they work through the same mechanism. Secrets and config maps both can be carried through that way, through the volume and environment mechanisms.
Is the architecture for this pluggable such that we could look at writing community extensions for things that are other than HTTP, but would still be logical for us?
So I actually left out an important thing. Thanks for the question. Can we use something other than HTTP for the intercept workflow? The intercept workflow is powered by Envoy Proxy. That's really important. I should have said that. I meant to say that. So anything that that Envoy Proxy understands, in the future, we should be able to intercept on that. At the moment, we have HTTP working really well. And the nice thing about having Envoy Proxy there is you can use intercept basically without worrying. Envoy Proxy can handle the load of your cluster and forward the majority of your requests through to the pod business as usual. So there's really no concern about opting in to using the intercept workflow. But yeah, it's built on Envoy, so whatever Envoy can do, we can get there with intercept.
First of all, that was amazing.
Thank you.
I had like several sort of mind-blown moments, so thank you for that. And my question is, does Telepresence itself run on the same cluster that you're debugging against, or can it run on a separate cluster somewhere else?
Well, so Telepresence is two pieces. There's the part that runs on your laptop, and then there's the part that runs in the cluster. And the way swap deployment works, it doesn't really swap out your deployment. It actually scales your deployment to 0 and makes a copy deployment that runs the Telepresence proxy code, the proxy image. So that part has to run in the cluster where all of the dependent services are. So in my example here, I had the Ambassador API gateway, and then the various services that we were working on, and then the upstream service, the base service. And all of those ran in the same cluster. When I ran the swap deployment, then Telepresence was also running in that same cluster. That's the way it connects to everything else.
Okay, thanks.
Hi. How does this exactly work with the liveness checks that Kubernetes does if your application is frozen in debugger?
We sort of trick around that. When we do a swap deployment, we replicate the deployment and scale the original to 0. The replica deployment, though, that is using the proxy image, we turn off a bunch of things. We turn off things like liveness and readiness checks. So if your cluster insists on those, I'm not sure if you can set that, but if your cluster insists on those, then things become more complicated. The other thing, I mean, you saw me pause these things for a long time and talk about them, right? The other thing I had to do was in my API gateway, I had to turn up the timeout, right? Because the typical Envoy timeout is 5 seconds or something like that. Obviously, I just don't type fast enough to debug things in 5 seconds. So in my mappings for the ambassador mappings that point to these services, I set the timeout to something longer, 5 minutes or something, so that I could debug. So yeah, it's not, there's always going to be other things that you run into when you're taking a live running system and pausing it so you can step through the code. And you run into them and you work through them.
Does Telepresence or Interceptor require Ambassador API Gateway, or is Ambassador optional?
Well, Telepresence does not require Ambassador. It's just convenient to use an API gateway to get to the services. Intercept is specifically part of the Ambassador Edge stack. So when we release all of that on December 10th, I'll be honest, I'm not sure exactly how we're going to slice all of those up. So please keep an eye out for that. But functionally, you don't have to be running Ambassador to use Intercept. But the product suite is tied together because it's all built on Envoy. It's using related technology.
Awesome, thanks.
Thank you.
Hi, the way I look at it with Telepresence, you have to take downtime to inspect. Could there be like a future version of Telepresence where you don't have to take downtime?
Let's think about how we would do that. So I guess the goal is we want to be able to grab a request and send it to the debugger, but not cause the application to fall down, right? So Intercept will let you do that because it's only sending a small subset of requests to your laptop. I might use a curl command, or I might use a browser and set the right header, set the right cookie, whatever it is. And so you could argue, or I could argue that that's not downtime because it's a developer-specific request. Another approach that maybe we could use is shadowing, right? We could say, Ambassador, send the request to the real service, but send a shadow copy to my Telepresence proxy. That might be another way we could do it in the future, where just because you're receiving the request doesn't mean that the original service doesn't get the request. That's another way we could pursue it. That's not a feature right now. Okay. I feel like Intercept addresses most of that concern because you're not taking down the whole pod.
Okay. One last question.
Yeah.
We have this use case where we have SOC 2 compliance where developers just can't see anything in prod. They can look at the logs, maybe Splunk logs, but other than that, like they're not allowed physical access to prod. Could this help with that, or is this a circumvention?
If you want to run one of these, you don't want to run swap deployment against prod because it brings down prod. Exactly what you just said, right?
Yeah.
But Intercept, I'm not going to say it's okay to run Intercept in prod, mostly because we haven't had it for that long and we just don't have experience, right? That's the honest truth. It's just not been around long enough for me to say that. That being said, it's built on Envoy. Envoy is super solid. There are plenty of people who run things like Istio in prod, and that puts an Envoy next to every single service that's running in the cluster. So we can probably get to the point where we can safely run Intercept in prod. The flip side of it is you should really have a staging cluster, and you should let your developers run wild in the staging cluster. I think that's the practical answer.
Yeah. But
Did I answer your question?
The thing is, like some services, they have 5 nines, maybe 6 nines of availability that they need to meet, but there's an issue in prod that they need to debug while the requests are coming in. So at this
we should talk about this offline
Okay.
because I want to write out an example, like a specific example, and think it through. It's the lights in my face. I'm not thinking as well as I usually do, so my apologies. But let's talk about that after I'm off the stage, please.
Sure.
Thank you. Another question?
So a question about what networking traffic's passed to Telepresence. So, for example, if you had multicast UDP traffic that your application listens to, would that be passed to your local machine?
Well, so Telepresence doesn't support UDP at all, multicast or otherwise. So we're not there yet. I understand that Envoy is going to support UDP in the very near future. It may have landed already. Envoy moves really, really fast, so it's practically a full-time job to keep up with its feature set. But yeah, when Envoy has UDP support, Telepresence will gain it too. It's something that people have asked about before. At that point, we can start thinking about what do we do with multicast. But yeah, we're not there yet. Question?
What is like the viability to use this as a tool to just replace like a Minikube or a micro K8s or something? To the
I'm
point
sorry.
where
Sorry to interrupt you. Could you repeat a little bit louder?
Yeah, sorry. Can you? So what would the viability of using this to do just pure local development without like needing a Minikube instance? Is that making sense?
Well, what do you mean by pure local?
Well, so obviously it wouldn't be pure local, but without needing to stand up all of my dependent services in a local cluster or some kind of local instance, and basically just do like a pure greenfield development on some application without managing like deployment resources and all of that in my cluster.
I mean, you could do that. Telepresence relies on the existence of a Kubernetes cluster to do the basic stuff that it does. If your goal is to write something that runs in Kubernetes, then Telepresence will make your environment look Kubernetes-ish. You don't have to swap a deployment. You can run Telepresence with the new deployment option, and it'll just make a new deployment that doesn't do anything. You can say, I want a new deployment that exposes this port, and what just happened? Well, anyway, I'm probably over time. So Telepresence will let you create the Kubernetes effect without having a deployment to swap. I think that answers the question. I was running these examples in a local cluster to avoid conference Wi-Fi. But yeah, this is typically something you would run against your developer cluster that's running in GKE or something like that on-prem, whatever. Last questions, though I think everything changed, so I suspect I'm being kicked out.
Yeah, we're slightly over time.
Okay. Well, let me hop off the stage, and I will chat down there. Thank you.